Hello everyone, welcome to another openQA live stream. Hope you're having a great day. Let's wait for everyone to trickle in. Let's get settled in. So this is more or less a continuation of the openQA live stream session from 2 weeks ago, and however, so don't worry, we'll start out slow. We'll start with a quick recap of what has been done last week, so that everyone who's new to this, who's never seen openQA, so that you can still follow along and don't get lost. Since this is a pretty nifty system, and it would be great if more people could use it, and especially to have more tests and all that. Quick disclaimer first. So last stream we tried to have a voice chat on Discord as well, but that turned out to be a little bit awkward. So I'm going to we're just going to stick with text chat for now. So I'm taking a look at the Twitch chat and on the chat channel on Discord, which is also bridged to Matrix. So if you write anything in there, I'll read that and I'll try to answer all your questions. And please, if you have any questions, if audio is off, if the video is slow, if the font is too small, too large, just ping me in any of those channels so that I can fix that. And with that, let's start out. So let's start first nice and slow. So what's openQA? openQA is a fully automated operating system test framework, which actually you can now currently see. So this is a local instance of openQA that is running on my machine. I guess one of the bigger ones is openqa.opensuse.org, which I will abbreviate as simply O3 because I'm too lazy to say all of that. So what does openQA actually do? So openQA is used to essentially give it a operating system, or you give it some form of ISO image or a virtual machine image. It boots it, and then it can run various kinds of tests on it. So the usual case for this is to simulate user input. For instance, openQA can do essentially all the stuff that a user can do. For instance, clicking, listening to sounds, and so on. So it's a really convenient way how you can imagine openSUSE Tumbleweed, which you can, not only because it's printed in big letters in here. So for those of you who are not too familiar with openSUSE Tumbleweed, this is that's a rolling release distribution, and there's a snapshot every couple of days, sometimes even every single day. And you want to make absolutely sure that every image that every snapshot that you publish, that the installer still works. Now you can of course have a huge QA department, and you can have 50 people just every single day burning ISOs on CDs, putting them into computers and clicking install and clicking through the installation, and that's certainly a nice way how to employ 50 people, but it's probably going to get boring real quick. And And because no one has such a QA department, openQA was created. And so let's take a closer look at this. So what openQA for Tumbleweed, for instance, does is, let's pick a nice example. It actually runs all these installation steps. And this is the part that you can see here. So, but let's first take a step back. So I've hopefully illustrated briefly what openQA is, and since this is the following part, this stream is going to be relatively openSUSE specific, but the general stuff about openQA is portable across all distros. So this is not only an openSUSE thing. It's used internally at SUSE. It's used by Fedora. Recently, actually yesterday, I found out that Endless OS is using it. I think there's even... I think there's some Ubuntu derivatives that are using it. So it's used quite across the spectrum. Good. So now that we got the openQA part covered, so so openQA presents itself as a website. This one. So this is openqa.opensuse.org, and what you can first see here, if you go to the main page, you can see so-called job groups in here. So here we got one for openSUSE Tumbleweed, we got one for Tumbleweed on ARC64, got one for the Windows subsystem for Linux, the Windows subsystem for Linux image of Tumbleweed, and so on and so on. So such a job group. It has here individual builds. In the case of Tumbleweed, these are the snapshots that get produced and then get forwarded to openQA for testing. And if we take a look at it, I just click on one of those. What you see here is a bunch of individual so-called test suites. And as you can see, there's quite a bit of these. So let's just pick one. So as you can see, in this case, since we're looking at x86, we have some for the 32 bits, and most of them are only run for 64 bits. So let's say, so these are individual test suites, and individual test suites consist of the actual tests. So let's pick, for instance, this one. So click on this, and now it will open the previously shown image. Yeah. Good. And so on this page, you see test. So this is the overview of one of these test suites, and here you see individual lines with a bunch of screenshots. Now, every one of these lines, this is a single test, and each of these tests corresponds to an actual file. And you can see that if you just click on it, it will show you the test contents. So for those of you who are new, this is Perl. If you don't like Perl, now is essentially your chance to run. I hope you don't, because openQA is very useful to have. and I would encourage you to give it at least a try. It's not Perl's reputation is worse than it actually is in practice if you don't do crazy stuff. Good. So now, what are these screen? So if you see here, there's quite a bunch of screenshots, and what each of these screenshots corresponds to is so every openQA test executes a bunch of individual steps. And as I said previously, usually it's stuff like press a key or take a look at the screen and try to find out what's if there's certain content on the screen. And each of these steps is shown here as a so-called screenshot. Simply there's a screenshot is taken and you can take a look what is being done here. So this test suite that I've picked out here, it's called Create Hard Disk Text Mode, and it does pretty much what the name would suggest. So the point of this is it boots the recent openSUSE Tumbleweed DVD, and it runs the installation in text mode. So it walks through all of these steps that you have to do to actually perform an installation. And in the end, it shuts the virtual machine down, and the resulting hard drive is saved and can be reused for later stuff. So now I said that openQA can be used to simulate user input, and if you now take a look at these individual screenshots here, you can kind of see what's going on. So here we are in the boot menu, and just a second. So you can see that there's no boot options entered here. openQA will then, I'm just guessing from this, so I haven't taken a real look at the test what it actually does, but my guess is it enters this text here, and then it will simply kick off the installation in text mode. So, and essentially we could now walk through all of this whole thing and take a look what's being done, and so on and so on and so on. So I hope that I got you kind of up to speed what openQA is used for, how the general concept works, and this is we spent on the last live stream quite some time on this. And the last on the last live stream, I tried to explain how this user input stuff, how it mostly works. And so let's go back to this step, and let's take a look at how that actually works. So if you start doing anything with openQA, you very quickly run into this concept of a so-called needle. So and a needle is it's just essentially a name for a concept that openQA uses to find contents on a screen from the video output of the actual virtual machine. So this is the thing is just called a needle from the programming concept of searching from this saying searching for the needle in the haystack. And if we now pick one of the screenshots, we can see this in action. So if you go to openQA and you select one of these screenshots, openQA will tell you, look, these are candidate needles, and it will show you what their how well they matched and which ones it considered. So now if you click on this part, you'll see the actual screenshot. So this is now the actual screenshot that openQA saw after booting the virtual machine, and it would now try to find the test would tell it to search for a needle. And now this needle is an image and image areas. And I think I'll explain it on a different example. So what I've got here is this is the Python needle editor. And so a needle is so you got yourself an image, and in the needle you define image areas. And in this case you can see, so the image is everything that you see in the background. Yeah? And the areas that are defined are these red rectangles. So you can have many of these. You can have just one. They can have pretty much any size. And now, what openQA will do is, if you tell it to search for a needle, it grabs the video output from your virtual machine, and it uses OpenCV and runs image recognition on that and searches for the specified areas. There's a few catches with this. So, for instance, if you have multiple areas in your needle, then what openQA will do is it will search for these areas individually. So that means if it, for instance, finds this image here, but it suddenly finds this one somewhere completely differently. So these areas are just they are defined, and they tell openQA where the areas for which it should search are in the screenshot, but they can match in arbitrary points in the actual output. So that means if you would, for instance, define your needle and say, okay, search for this part, and now suddenly in the background there would be something that looks similar, openQA could say, hey, yeah, I found this part here and this part there. And so that's something you should be wary of and take that into consideration. So these are that's the areas. For information, so all this stuff is saved in a JSON file. So that so in case you want to edit that later on, and for instance don't have the needle editor, in here you can also do that directly, but in most cases you use the developer mode of openQA that's used to edit needles, and that's what we'll do in just a minute. So far, any questions, anything unclear, anything specific that you'd like to know? So I know I've rushed through this quite a bit. So just anything that you'd like to have explained in more detail, or otherwise I'll jump and we'll start writing some actual tests. Doesn't look like it. Okay, so let's take a look at writing actual tests. So since this is going to be since this is an openSUSE specific test, we are going to work from the openSUSE test cases. And you can find the openSUSE test cases on GitHub under the OS Auto organization in the repository OS Auto inst distri openSUSE, where all the tests and bunch of tools exist. So if you want to write actual tests, we should maybe let's say first you should of course think about why do you want to write an openQA test, and what for, or do you want to just make a bug fix or something like that. So if you would want to write an openQA test, then openQA is really it really only makes sense to write tests for something that can't be really tested feasibly otherwise. So it's not really great, for instance, for to just run unit tests of a package. So you'd really want to do stuff like run the installation procedure or also to test GUI applications. So for instance, if you want to ensure that Emacs still works, yeah, so that if I do this part, that Emacs will open up, yeah. That's kind of hard to pull off in anything else, and so for that, openQA is quite handy and quite useful. So to make our life easier, since openQA can be relatively daunting and sometimes not easy to grasp, I lost the tab, sorry about that. Yeah, so here we were. So we'll start out with the simple case that that there's an existing test and we want to improve this one. And so how would you go about that? So I assume if you actually want to do something about that, then you have a specific test in mind. But if you are very bored and you just want to fix one, and you could then you could just open openQA and take a look at any of the failing tests. And so that one, I mean, so in just as a explanation, so green means it the test passed, gray is cancelled, blue, do we see any blues here? No, this one already ran, but here there should be a few blue ones. Blue means scheduled. Oh no, sorry, this is light blue that's running. This is scheduled. Yes, that's scheduled. Red means it failed, and yellow is soft failed. Soft failed is something like as far as I know, it essentially means there is an expected failure that's I think soft failures, it's essentially it's expected to fail, but it's not a real failure. So for instance, we have a transient bug that we know about, and so this is expected, but it's not really fatal. So let's say, okay, in my Emacs example, okay, I know I'm currently working on fixing a bug, and if the and to get this bug fixed, I need to submit a patch, and this patch is not yet there, so I'd make this test just soft fail if it triggers this bug. So let's say I want to take a look at one of the actual failures, and if I want to start working on the test, if you click on this one, on the test name, then you'll see then it will open the actual file, and it will also show you the path to this test. Yeah. So in this case, it shows you the full path. So this is openqa.opensuse.org, and what the setup there is that the GitHub repository is checked out in the openSUSE folder. So this is under tests x11 GNOME case application starts on login, and if we would go to GitHub under tests, I already forgot the path. So x11. x11 GNOME case. And there we have it. Application starts on login. Yeah. And so now you see this should be the same file. Looks pretty much the same. So and you can go about this in the and now you'd go about this and just check out this repository, and then you can start working on that. So I got that part already here. So let's just as you can see, this is a local clone of the OS Auto Inst distri openSUSE repository, and I already got a test here open. So as you can see, we could simply take a look at the files in here as well. Good. So for this stream, I have already prepared something. So let's let's now go to my local instance, which on first glance looks totally the same like openQA.opensuse.org, except for it's running on my machine. So this is my this is running on my local computer. And if you want to actually get into writing openQA tests, I would highly suggest that you grab yourself that you set up yourself an instance on your local machine, since you can run jobs on O3, but O3 has only limited resources, and at some point, if you start bombarding it with jobs, Oliver Kurtz is going to probably be very mad at you and ban you. Or someone else will, because you're hogging all the workers, and it's a lot more convenient to run the tests locally. So I would definitely suggest that you grab yourself a local instance, and if you're curious how to do that, this is explained in the documentation. So if you go to open.qa and go to the docs and open the whole documentation, there is so what I'm using is the quick bootstrap, and so this is in this quick bootstrapping under openSUSE. And I'd say just take a look at this guide, but it's really just these two lines that you have to execute, and then you oh sorry, in the container, this one. So this is what I'm running. So my local openQA instance is in here, and as you can see, so this is openQA 1. Okay, so Oliver will not ban you. He just said that in chat. So there's some capacity. Good. So we so back to my local instance. So we I have prepared something for this, and what I've done, I've written a very simplistic test for Emacs, since this is it's my main editor, and as far as I know, there's no tests, and the tests that I've written, you can see them here. First thing is boot to desktop. This is actually not written by me. That's just that just does essentially what you'd guess it does. It boots the virtual machine to the desktop. Couldn't get any simpler. And then I've created a very simple one. So prepare is prepare just installs Emacs, it starts it, and then it just kills it again and ensures that it works out. The second test is called I've just called it launch, and what it just does is start Emacs, open a file, and we can we'll take a closer look. And the last one is an actual regression. So that's a test with respect to fonts and some GNOME config tweaks. Since there's been I think some issues with that, or I think that I've written that as a regression test for a GNOME settings thing, but let's not get ahead of myself. So in any case, so if you now take a look at at such a test suite and you want to find out what it does, a nice way how to find that out is to go into the logs and assets tab, and you can just take a look at the video. So this is, as I said, openQA grabs the output of your virtual machine, or actually, I keep saying virtual machine, but actually openQA is a very flexible thing. So it doesn't have to be a virtual machine. It can actually work on bare metal as well. For instance, it can work on a Raspberry Pi. Yeah. So this is kind of a pet project, but Guillaume Gardet already set up some Raspberry Pis on openqa.opensuse.org, and there you have an actual Pi that's where the tests run on bare metal. But in most cases, the tests run in a virtual machine, and you can take a look at the resulting video. And so, just to get a rough guess what is happening, we can wrap the video. So this is greatly sped up, but we take a look. So you see, okay, here we have grub. That's selected. Tumbleweed boots. The system logs in. So there's no, in this case, there's no login screen. That's just the way it is set up, but that's just to make things simpler. Then Xterm is started. This is just the so what's happening here? Here Emacs is actually installed. That's the root password. Yada yada yada. Okay, Emacs is getting installed. Then Xterm is closed. Emacs is launched. Closed again. Now we are in the second test. So here we launch Emacs. Open a test file. Close it again and just check that the file contents were actually written. And now this is the font test case. So that's useful if you want to. So taking a look at the video is generally quite useful if you want to get get something. If you want to get a quick overview of what is actually happening, and but you can certainly also look at these screenshots here. Good. So let's take a closer look at how these tests actually work, or how they look like in practice. So this is the prepare step. This is you could give it any name you like. As I said, these are the tests are written in Perl. That's just the way it is with openQA, because it's it was just written in Perl, and so the tests need to be they are also Therefore, they are also written in Perl. So what openQA does, you give it one of those, you give it a test file, and you have to define a function, or in Perl speak, it's called a subroutine. That's called run. And in this, you put several openQA test commands, or stuff from the test API. Yeah. So, for instance, the first thing is ensure installed, and a lot of these do more or less what you would expect them to do. So ensure installed it installs the packages that you give it. In this case, this is Emacs X11 and Emacs NoX. So Emacs X11, that's the GUI version, and NoX is the one that runs in a console. X11 start program. This is used to launch an actual program under X11, and this part here is send key. Is again, it's kind of self-explanatory. So it tells openQA, send the following keys, send the following key presses to the virtual machine. Now this part might be a little weird. So this is, but what it essentially does in a nutshell. So this is a Perl syntax. If you are more familiar with other language, with for instance Python or JavaScript, or let's call them more modern languages. So what this is actually a function, and this is and this would be an anonymous function. And what happens here is you are telling openQA, send these key presses to the system under test, and wait until the screen changes. So yeah, I hope this makes kind of sense. So this is so it essentially, this is a function that wait screen change is a function that executes this internal function, these functions in here, and then waits until something happens. And for those of you who are not Emacs users, Control X, Control C, that just closes Emacs. So you would kind of expect for the screen to change. So for instance, if I now open Emacs here on my local machine, and I press Control X, Control C, it closes, and so the screen should change. Now, I conveniently skipped over this part. X11 start program, and I skipped over this target match. So what this means is, what this function from the test API actually does is, it opens a test runner. It opens a application launcher. So this is imagine under GNOME. That's what you get if you press Alt F2. I'm not running GNOME, but I think this is Rofi. I think it's called Rofi. So that's essentially what it essentially does. It opens your launcher. It enters the text. And then it tries to, and then it looks for a needle with this tag Emacs. And what target match says is look for a needle with this tag. So I didn't really explain what tags are, and let's take a look at that now. So I've got here. This is the repository with all the needles on that openSUSE uses. And as you can see, we got those pairs of image files and the corresponding JSON files. So let's see. I've previously showed this RStudio needle. And what, let's quickly see. So this is the file name, RStudio desktop, about RStudio. So let's take this one. So the image is yeah, that's the image, and that should be more or less what we see here. Ah, no, it's actually the other one. I'm not mistaken. Ah, sorry. No, it's the one from January 3rd. Ah. Yeah, I know GIMP. Sorry. Yeah. So if we compare this, yeah, this is the same image. And there's now a corresponding JSON file. And that's not how JQ works. So this is it. Ah, there's someone new in chat. Hi, X3M Linux. Welcome. I hope I didn't miss you being there for a while. We are doing openQA stuff. So this is so we are currently at taking a look at openQA needles, and so the JSON file, it encodes the areas that you can have here, and it can have additional properties that would be here. So as I said, since openQA uses openCV, you can define additional stuff like how exact should the match be. So in certain cases, it makes sense that that there's a certain amount of fuzziness that you can employ for your screen matching. And you can for instance use that if you have if your fonts could change slightly. So this is unfortunately one of the nasty problems that you sometimes get with openQA is if for instance your font rendering library changes and it employs a better anti-aliasing or something like that, then your screenshots don't exactly match what you get now, since if HarfBuzz is now suddenly better at rendering your fonts and your ligatures look differently or the spaces change slightly and your matches are set to be really, really precise, then they will just fail. But if you give them a bit of fuzziness, then all should be good. Or it you can't be too lenient there, but it should sort of kind of work out. But my actual what I wanted to talk about here is this tags field. So a needle has tags. Usually you only have one, but you can have multiple. And these tags are what openQA actually uses if you tell it to search for a needle, which I found initially very confusing, since I thought I tell openQA, hey, search for this needle called RStudio Desktop. And so I would have expected, okay, it searches for the file that's called rstudiodesktop.png and .json, creates a needle from that. But no, that's not the case. It searches for tags. And it might appear confusing in the beginning and just sometimes plain out annoying, but it is actually very convenient. And excuse me, I think I can quickly show you when it is. Yes. So for reasons that I might explain later, at the end of this test, openQA will automatically check that that we are back again on the ordinary desktop, and it does that by searching for a needle with the tag generic desktop. And if you now go to the actual so if you click in the openQA web UI and take a look at the needles with the at the tags, openQA will show you all the needles that have this tag. And if we click through them, you can see there's quite a few with the tag generic desktop. For instance, wait a second so that I can. Yes. So this is just one of the. I should probably explain this part a little bit better. What I'm currently doing here. So this is the. What you can see here is this. This is the screenshot. This is the part that openQA actually recorded. And if we select a needle, we can drag this slider around. So you can see on the lower part, this is the screenshot from the needle, and this should be from. Yeah, and this part is the actual screenshot. And this one should be the area that was used to match. And if we go here and click on View Full Div, it will show on the left part full needle and on the right part the screenshot. And now if we go to this one, you'll see Windows. So this might be surprising, but although openQA is used for mostly for Linux distributions, it's not Linux specific. You can test Windows with it, and I think we actually have a few tests for Windows that we use for testing the openSUSE WSL images. And if anyone happens to be currently in the stream from a different Linux distribution, you can do that yourself. So you can just you can make openQA install Windows. That's not an issue. So the whole framework is operating system agnostic. There's no, you don't really need to be running Linux on the system under test. Yeah, so as you see, I'm really good at getting carried away. What my actual original point was needle tags. And the thing is, this needle, this Windows network setup, yada 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 thing, it also has the tag generic desktop. And let's take an actual look. So this is called Windows Network Setup Generic Desktop. Let's go to the repository. So Windows. Oh yeah. Windows Network Setup Generic Desktop JSON. Yeah, and you can see it has the tag generic desktop. And so my point being, the advantage is I can now just tell, I can have a whole bunch of tests, and at the end of each test I can just say, hey, check that you are now on the desktop. And in most cases it would be very unlikely that you start your test under openSUSE with the GNOME desktop and suddenly your test terminates on Windows. I actually cannot think how you'd manage to do that, but in that case it would be bad. But in most cases you just want to say, okay, hey, yeah, I'm now back at the desktop. And that means you can just have the same line of code that just says, hey, try to find a needle that's called, that has the tag generic desktop. And the same, and you could then have the same code that would work with Windows, that would work with GNOME, that would work on GNOME with Leap, that would work on a recent GNOME with Tumbleweed, and so on and so on. And you can, as I said, you can have tags, you can have needles with multiple tags. So that's also not a problem. And that's also sometimes very useful thing to have. So that's hopefully, yeah, we were at the prepare thing. So that was a relatively lengthy explanation what's going on here. But essentially, so coming back to my original prepare test, that's what this target match part does. So it searches for a needle that's called that has the tag Emacs main window. And if we now go in here and open this one, yes, then we'll see. So you can see here that it tries to search for the needle with the tag Emacs main window, and it finds one. And this one is from yeah, I created that needle already 2 weeks ago, so it's from yeah, more or less 2 weeks ago. That's why the date is different. You can see this is your so these are the match areas that I defined. And if we now switch to the full div, you can see here, so this is when the screenshot was taken, since there's a clock, and this is the actual image. Good. So let's let's work on this. Let's get to some actual coding since we're already an hour into the stream and I haven't really touched anything yet. Let's demonstrate a few parts of what openQA can do. And let's therefore take this prepare step and do a bit more stuff with it. So what we'll do for that is if you would now say, okay, hey, I got this, I found this test here on O3. So you would go find this test, find the corresponding file. So I've got it here already in prepare.pm. Yeah. So you can see this is the same file, and I'm going to now start out with an existing file since that's a little bit simpler in terms of adding it. And we're going to do something so for demonstration purposes, let's do let's show what Emacs what we can do with openQA. So what we are going to do now is and I'm going to show that on a fresh Emacs instance. So we are going to make a relatively pointless, but for illustration purposes, a test that we're going to tell openQA to find the menu entry tools, and we're going to tell it to click on calendar. And what then will happen is openQA will, Emacs will open this this buffer with the current calendar. And we'll then check that this thing is actually open. And what could we? And I guess what we can also do is then say if we press Q, it will close it. Go to the buffers menu and click on calendar again, and then press Ctrl X, Ctrl C, and close it. So let's go with that. Yeah. So we're going to tell openQA, press on find tools, click on that, click on calendar, check that this calendar buffer is open, press Q, then find the buffers menu, click on calendar, check that this is again correctly opened, and then close Emacs. We are going to do it the complicated way so that I can show you more how you would go about creating needles and so on. In practice, you want to avoid matching too many needles since that's relatively complex. So in the case of Emacs, you would go rather with MX. So you would try to do as much as possible via shortcuts. So so what many programs support is if you hold down Alt and that you can go to the menu. With Emacs, it's of course different since Emacs is different to everything else, but we are going to go with clicking so far. So now we need to tell openQA to click somewhere. So how do we do that? And as usual, a good start for that is the documentation. So I've got myself the so if you want to write actual tests, a good start is the is other tests to take a look at them. This live stream, of course. Sorry, had to do that. And most importantly, the documentation of the test API. So this is also under. It's also under openQA. And if you, so I showed you the documentation, the official openQA documentation previously, and if you, and I think it's linked in here, if you search for test API, then you'll find the link in here. I have it already open in here. So clicking is done via the function assert and click. And what you essentially, so you can see assert and click takes a bunch of arguments, but the most important one is must match, and that's the tag of the needle that it searches for. And you might be now wondering, yeah, but how does this clicking work? So I'll demonstrate that just in a second. And one of the parts, one of the cool parts of openQA needles is that you can define areas where openQA should click. So we are going to tell openQA that it should search for a needle, and we're just going to invent a relatively unique tag name for this. And I'm going to call it Emacs main window, tools menu. Maybe we can call it also tools menu click. So that will open this tools menu. And then we want to make another click on the tools calendar. Welcome. 1 hour late. You missed all the interesting parts. Well, you missed the recap. We are currently writing a test case for Emacs. So just to get you up speed, I've created a simple test case, simple test for Emacs that essentially. I see I'm scaring people. It's not so bad. We can write another one for VI, but I guess there is already one for VI, and with VI I'll probably embarrass myself because I still know how to quit it, but that's about it, what I can do with VI. So the current plan is that the test will... What I plan to do is that the test will open Emacs. It will click on the tools menu. It will click on calendar. It will check that this calendar buffer here opened. It will press Q, which will get back to this one. Then it will switch back to the calendar buffer via this menu. And we'll just close Emacs. And what I'm reusing for that this test that I've so I already had this part and this part, and now we are adding the part that will do the actual clicking. So that's being done by this assert and click function. And what that does is you give it a needle. So you give it a needle with this tag, and this is just the one that I invented. Okay, so okay, Oliver doesn't care about Emacs. If there is any Emacs users in the chat, please please give him. Well, no, I'm not going to conjure any hate on anyone. I understand why Emacs is not tested, since, well, VI is actually, I think, even part of a standard that's required to be on Linux. But let's not get carried away again. I know I'm really good at this. So we were at this step. So we're going to tell openQA to find this tools menu. Click on that. Click on this calendar menu. So I'm going to invent that needle. That's being done. Okay, so if you are writing a new test, it's usually useful to not make one step at a time, since these tests take a while to actually execute, and you can fix them to a good chunk on the fly. So just take as many steps as you reasonably can, and try to fix as much on the fly, since it's going to make your iteration steps a lot faster. So what did we want to do? Tools, calendar, press Q, and then switch the buffer. So we're going to tell it, wait for the screen to change, send the key Q. And actually, since this is just a single key press, so if we go to the documentation of the test API, this is a good thing to have open if you're writing tests at all times. So send key, where is the documentation of that? Yeah. And this also takes a parameter, and we can tell it to wait for the screen to change. So you don't always need this part, but bear in mind, most of your essentially most of the tests run in a VM, and the VM is usually it can be on a system that's under high load, and so if you send it a key, it takes so you send it a key via a VNC connection. Now it ends up in the VM, and then you get the video output back via VNC, and that's analyzed by the worker. And and all this takes a certain amount of time. And what you usually want to do is you want to ensure that your system is in a specific state if you before you send any further key presses. So, for instance, if the escape key closes something, you want to and then you want to send further key presses, then you want to make sure that the thing is actually closed. And if you have if there's a certain lag, you can sometimes have nasty race conditions. And so it's usually useful to, if you know my key press will change the screen, then to put, if it's just a single key, to put this wait screen change parameter there. And that's what I'm going to do here. Wait screen change 1. So this is how you would put optional parameters in Perl, or Actually, I think this is actually a hash graph. I'm not a Perl expert. I'm sorry, but so all the Perl experts are free to correct me. But for those of you that just want to write openQA tests, see this as optional parameters, and it will work. It will do the right thing. So what this will do, it will send the key queue and wait until the screen actually changes. But I think if the screen doesn't change, then it will not fail the test. But you can, if you want to know, you can find out if the screen changed. So we are at that part. So I'll again reiterate my test plan. So tools menu, calendar menu, press Q. And we are going to switch to the calendar buffer. So a buffer is just in Emacs speak. It's just a different. That's just a different open editor window. So it's just a name from the 80s that was never changed. I mean, I guess VI has its own ones, and we could now do that via clicking as well, or we can use Control X B, and enter calendar tab and switch via that, and that might actually be a bit faster. So. And will not require fiddling with so many needles. So we'll do that. But now that I'm currently thinking about that, what we should really, what we want to also test is that if we are, if we have the calendar open and we press Q, we want to make sure that that this window is open. So we should check that the screen actually looks like this. And so we are going to just check that a needle matches, and that's done via assert screen. So that's kind of we give let's do the good thing and go to the documentation, assert screen. Whoop. And as you can see, you can specify again some parameters, but mostly we are interested in the first one, and this is the needle tag. So it should match the needle that we have to that we'll give it a tag. So someone's suggesting to test evil mode. We can actually do that. That will be a little bit more interesting, since evil mode is not in Emacs by default. You know, we can give it a try if you if the chat wants it, and feel free to disagree. Okay. So Fed. I see. I should really start putting in the Twitch chat onto into the stream, since now Fed Paglesi, I'm sorry, I probably butchered your name, is suggesting to use Emacs built-in terminal and then launch VI there. I'm pretty sure that's going to be a terrible experience, so let's maybe not do that part. Let's first finish our calendar test, and then we can maybe try evil mode. That will be interesting, since we'll have to install it at first, but that wouldn't be too bad. And you can all have a laugh at me when I struggle with Vim key bindings. So now we're going to let's get back to the actual test. So one of the things I'm currently not sure about is the following. If I'll so in my test, when I launch Emacs, I get presented with this help window. And I guess if I open the calendar and press Q, I'll land back again on this. So I think I'll try to search for Emacs for a needle with this tag, and let's see how far we get. Maybe maybe stuff will break, maybe stuff will work. We'll see. So we're going to guess that if I open the calendar, press Q, that I land back on the main screen. And we're going to press Ctrl X B. This will open here in the so-called mini buffer. Will prompt us to which buffer we want to switch to, and we are going to want to switch back to calendar. So we are just going to enter calendar, press tab, press enter, and then we should be back again in the calendar buffer. And you know, I got way ahead of myself. I completely forgot that we actually want to check that the calendar buffer opened. So calendar, I misspelled calendar. You guys aren't looking over me. You should ensure that my spelling is correct. Yeah, so we're going to open the calendar via the tools menu, check that it's there, close it, check that we are back at the main screen, and now we're going to press Ctrl X B, and we're going to do for that. So we are going to reuse this send key. And I'm not sending this in one single command. I'm so the thing is, if you go for in Emacs, this is just the key binding just works that you first press Control X in one, and then you press B later on. I don't think it would work out if you press that in one. So we're just going to that, yeah. Okay. Okay. What are you using for completion? Is Fat Puggles asking. Do you mean completion in the main window? So as this part, or do you mean if I do stuff like this to switch buffers? So this is just company mode, plain dumb company mode without any Perl specific configurations. So I tried, yeah, it's nothing special at all. This is plain Perl mode. So the auto completion that you see here, that's actually let's actually check that. I think company diag. I'm actually not sure which backend does this, but I think it's yeah, it's just the dumb Dabref completion backend, which just scans the source code for existing stuff. So I tried to use LSP mode, but it wouldn't really work. Unfortunately, I don't have a great setup for openQA yet, so it's it unfortunately happens to me that I just write invalid Perl and then the test fails. Yeah, so we are now in the switch buffer menu, and now we are going to type, and now we just want to type a string, and well, there's a function for that, and it's called type string. So we are going to say calendar, or we're going to say just a shorter one, and press tab. And enter. Enter is called ret in openQA for this send key function. So if you go to the documentation and search for the send key function, then you'll see all these special characters here, and you'll see there should be somewhere there's tab, and enter is called ret for return. So that should switch to the calendar buffer. So I'm just going to check that quickly and close Emacs. And that's it. Good. So what I'm now going to do is I'm going to quickly push the... So I'm just going to make a commit. And push these to my own fork to pull them down on my test instance. This step is optional. So if you got yourself your own openQA instance running on your local machine, which I have, as you can see here, give me a second. So I'm just going to pull the changes down. So what you can, of course, be doing all the time, you can just edit the tests directly in here. So I can just go here now to tests, x11 Emacs prepare, and I could be editing them in here all the time, no problem at all. So that's you can certainly do it this way. You can do the Git way just as you prefer. I tend to prefer to edit them here on my machine, commit to Git, and then push and pull that down, just so that I got stuff committed already. And because this is running inside a container, I don't have my ordinary Emacs setup in there. But that's just a matter of preference. Now we're going to actually launch the test, and for that I'm going to clone a job. Is this the correct one? Yes, it is. I'm going to skip explaining how this monstrous command line works, how to find out what to enter here, since this would probably take us the rest of the stream. Maybe I'll say a bit about that later on. But usually how you want to run tests is that you clone existing jobs. So this will now it will now check to download some stuff, but I should have that already on my machine. Yes. So it created a new test. Let's get quickly to my instance in here. I'm going to jump onto the live view. So what you now can see here. So this is the actual machine that's being booted up, and what I'm now going to do, I'm going to switch into developer mode, say confirm to control this test. Sorry that I'm running so fast here, because I need to tell it that it will pause on an error and not just fail the test. So what I've now done is I went into the developer mode. And this is used to, so this is essentially used for the stuff that I'm going to that I'm going to show you now, and that is sorry. And that is to create new needles and to edit existing ones. So as you might probably guess, let's get back to the test that I've written here. Yeah. I said previously that I had just made up this needle name, and that on the other hand means this needle doesn't exist yet. So we need to we need to create it. We could now, of course, open Emacs ourselves, create a screenshot, and write the corresponding JSON file, but that's terribly inconvenient, and no one does that since that's really hard to pull off. So we are going. So openQA has a developer mode for that, and this is exactly what I've switched to. So if you have yourself your local openQA instance, or if you are on, if you are I think you have to be an operator, or you have to be you have to have a certain permission level on openQA. It's on, for instance, O3, and then you can switch there to developer mode as well. But on your local instance, you just have to log. You just have to log in. And what the developer mode does is, if you now say you now tell openQA, hey, look out that you find this needle, and it doesn't find it, in a usual test it would just fail. But in this case, we told it pause on screen mismatch on if an assert screen fails, then it should pause and not fail. And that just happened. So but now take so let's see. So we would now expect this part already existed. So I expect that openQA searched for this needle and didn't find it. Simply, since the needle isn't there, it couldn't find it. So we can verify that by going here on the openQA page and going to the live log, where you see the output from you. So this is the mostly debugging output. And let's take a look what happens. So test API, yeah. Emacs main window tools menu timed out after 30 seconds. No matching needles. And the issue is simply this needle doesn't exist. So we are going to now use the built-in needle editor. And this is the usual way how you would go about creating needles. So this is your needle editor. And you can now use this to create a new needle. Let's go through this first step by step. So most important thing is the needle name. So usually you can just stick with the name that's already suggested in here. So what it just does, it prepends the name of this test module, then the main needle tag, and the date. Yeah. This one would be filled if we would have recreated this needle, but we're not going to do that. And now, if you are creating a new needle, don't forget this part. Yeah. So as I said previously, the name of the needle, we could actually call this also this, but as long as the tag is correct, it would work. I mean, this is a terrible name, so we're going to stay with the default. But the file name is actually not that important. It's of course important to have a decent file name, but it is not related to the tags. Yeah, so ensure that the tag is there. And as I also said previously, is you can have multiple tags. So if this needle can be used in different contexts, we could also add another tag here. I might actually reuse that later on, but now let's take a look at the actual creation of this needle. So this one was to look for the tools menu and click on it. So here we have our screenshot, and it would now be now we can simply do the following. I can just drag with the mouse here and define areas which openQA will look for, and that it will try to match. And so general recommendations is try to find a few areas of your that are not too large, that preferably will not change with time. So this is a terrible area. And I mean, this is the worst possible area, since it will always mismatch unless it's July 29th, 8 a.m. So take areas that are constant in time, and preferably that will not change with releases. So if you want to match, if your needle contains a version number. So if I would, for instance, say, okay, I'll define this, I'll put this area here, then this needle will search for something that looks like GNU Emacs 26.3. And once Tumbleweed updates to GNU Emacs 27, the needle will no longer match. And it really, I mean, it depends on what you want to test for. If you want to really, it is important for your case to check that this is actually in there, then by all means do that. But I would highly doubt, for instance, that it's useful to test in openQA that it was built with GTK 3.24. So now for our specific example, so we don't want to be too lenient, but we should check that we really have Emacs open and not something different. So checking for the Emacs logo is not bad. We can also check that there's actually Emacs, and if we want to, and now I said we want to click on the tools menu, and we can do that by, so we are going to also define this area, and now, so you can select these individual areas by just clicking on them. You can drag them around, you can resize them and whatnot, and then you can also go here, okay, I'm going to add click coordinates for assert and click, and you can also remove them. And so this circle is where openQA will then click. And so we're going to just, it's by default in the center. You can move it in to any point inside the area, but I'm just going to keep it in the center. Yeah, and I think this is this should be sufficient. So let's just let's keep this one and save the needle. Yeah. So now it's at needle created, updated, back to live view. So let's go back to the live view. And now the expected happened. The screen is black. Yeah. So this is usually what happens if you take too long creating your needle. The screensaver opened. the screensaver popped up, and now, yeah, well, damn, what do we do now? Fortunately, openQA is also already here helpful, and it tells you how to connect via VNC to your virtual machine. So you can just copy this part. In my case, I'm going to, since this is running inside a container, it thinks that it's called openQA1, but it's actually localhost. Yeah, so, and if that happens, whoop, just, so the default password, at least for the openSUSE test cases, is not secret. So it's not secret, but instead of ease, you have a 3. So let's just unlock it. I'm going to move the mouse out of the window, kill this. Yeah. So now I see we are back. And we go to resume test execution, and it's just going to retry matching for that needle. Yeah, as you can see, it actually clicked there. Now if we go to the live log, we'll see that that it tries to search for the same needle, and it will do that for 30 seconds. But this needle also doesn't exist, so we can safely click on skip timeout. Wait for a second, and now we would essentially repeat the same step again. So yeah, this button really loves to disappear sometimes. So we're going to go to Open Needle Editor, and now we essentially want to do the same thing again, but just with the calendar menu. So we're going to just define some areas, ensuring that we are actually in the tools menu and that it's open. So, and yeah, as I said previously, these the areas in that you define in these needles, these are not fixed positions. Yeah. So what I think openQA does under the hood is it extracts these areas from the image, and then it uses openCV to find them in the video output. But the match position is not constant, which is really convenient if, for instance, Emacs would open in a different size, and now it's just, imagine it just being shifted by 10 pixels to the left. If this position was hard-coded, your needles wouldn't match. That would be very inconvenient. So it makes sense to do it this way. But it's just something to keep in mind that, for instance, if in your background there's a thing called that also says calendar, openQA could find that. Yeah. So keep that in mind. So we're going to click on that, ensure that the tag is there. You can also, in case you're interested how the resulting JSON looks like, can take a look at that. But yeah, I'm going to, it's maybe sometimes useful to check that your that you have the right amount of areas. So save. And let's go back to the live view. And since we weren't that slow this time, we can just directly resume the test execution, and we'll hopefully, yep. See, so it already found it, clicked it. Great. And now we're going to have another timeout, and that's, yeah, this needle also doesn't exist. So we're going to skip the timeout here. And now we need to, oops, what did I do? Oh, sorry, I switched to a different tab. Yeah. And now we need to create a needle that will check for the calendar buffer. We're going to open the needle editor. Yeah, now we have to think about how we're going to create the needle. So, as I said previously, if this test is submitted to the actual tests of openQA, it will not be it will be run all over the year on all possible dates. So for instance, checking for this for that there's July 2020, that will work for this month, so that will work for only about a month. And once it's September, there will be no more string that says July. So that's not really a great area. So we have to check that there's actually for other parts that are preferably constant in time. And in this case, yeah, we want to just know, okay, there's a calendar, so let's just match this one. And we can certainly, I think it's also safe to assume that the days are going to stay the same. So let's just check for all of these. I would actually exclude maybe Sunday from this one. And let me just check very quickly something. Okay, that's appears to be an Emacs thing. So the thing is the following. I'm not sure how Emacs handles this, but whether Sunday is the beginning of the week or the end of the week, that might be possibly locale dependent, and you don't want to rely on that either. So so I'd exclude Sunday in case, for instance, it would appear here, and if I would include it, then suddenly the needle wouldn't match again. But maybe I'm being paranoid here, so it's probably not too important. Yeah, and so as I said, I would definitely not do this, but still it's safe to assume that we're going to. It's safe to check that we are still in Emacs, and I'm skipping this @SUSE test since SUSE test is the name of the virtual machine that is running this, and I don't want to depend on that being run, on that being the case. So that should be, I guess that should be good enough for now. So let's save it. Go back to the live view. Resume the test execution. Okay, so let's watch it. Now it pressed Q. Okay. We are back at the main window. Now what's happening? Okay, something didn't happen. Let's take a look into the output. Okay, so needle. Yes, so this is the needle that we just created. Then it did send the key Q. If we take a look at the test, so this part worked. Then it should have checked for the Emacs main window. That also worked. So yeah, found it. Okay, so then it sent the key Control X B. And now it's there. And for some reason, okay, so I'm afraid what now happened is it should have actually sent the string. Because as you can see now, it's waiting for this calendar. It's already looking for calendar buffer, and it completely skipped over this part. Yeah, and you see, it's because of this. There's a semicolon missing. Yeah. So as I said, my Perl setup is not perfect. Yeah, that's unfortunate because this is one of those issues that you can't really fix on the fly, unfortunately. So what we're going to have to do now is just kill this test. Just going to quickly push going to push that, pull it down, and restart the job. Yeah, so in case you're wondering what happened here is I simply in the previous one I simply forgot about the semicolon, and then it doesn't then for Perl that's no longer a command, but I think it's yeah, I'm not unfortunately not too familiar with Perl, but it essentially means that it is no longer, that it will just not execute it, which is in this case unfortunate, but yeah, we can just restart the thing. So as you can see, it's currently booting, so we're going to jump quickly once going to go to live view. Hello, can I please get my, yeah. Going to control the test so that I can actually, it will actually not fail. Since we're going to have to wait a bit for it to install Emacs and run the previous stuff. So what you can also do in the developer mode, you can pause at certain modules. In this case, it's a little bit not too useful actually, since we don't have any additional modules. But let's go into this one. So if you have a lot of modules like this specific test here, what you could do then in the developer mode to tell it to just run and pause briefly at a certain module. If you, for instance, want to check something before the test executes. Yeah, and I think looks like I was talking and now the test actually succeeded. I'm a little bit surprised since... Oh, okay. Yeah. Let's wait for this to actually finish, and then I can explain why this worked out. So the first try failed because I forgot the semicolon here, and it just didn't switch. So now let's take a look what happened here. Is openQA, please. Okay, my machine is a little bit under heavy load, so I thought this doesn't. Let's just reload. Yeah. Okay, so we created this needle. Click on tools. Then created that one to click on calendar. Then it matched this part here. That's all nice. That all worked out. Yeah, and so this is the needle that I also showed you how to create it. And remember how I said that these areas are not in fixed positions, and that what so this is the needle with the tag Emacs calendar buffer. So if we take a look at the actual test, it appears here and it appears here. So now what's so we are now in this step. No, sorry, we're here. Then it would have printed Q, pressed Q, and checked for Emacs main window. So that worked out again. Let's go to this full diff view so that we can actually see. So the left-hand side is the needle. The right-hand side is the screenshot. What you can usually see that via by just comparing the dates. So that's the main window, and now we send the key cord to switch to a different buffer, and switch to the calendar buffer. And now you see this is again the needle called Emacs with the tag Emacs calendar buffer. We now go to full diff view. So this is the screenshot that was made. Yeah. And this is how the needle looked. This is the needle screenshot, and we defined the area here, here, and here, and it matched them down here and up here. And yeah, so this is in this case very convenient, since we have more or less relatively reliably ensured that we actually opened this this thing, but its position on the screen is not really was in this case not important. And here it was really was a really big advantage, because we didn't have to check that the calendar is actually down here. And so if these positions of the areas would be fixed with respect to each other, then we would have had to create two needles. In this case, we didn't. Okay. So I'd say since it's already getting around 13 p.m. UTC, and I've been now rambling for 2 hours, and my voice is starting to crack a little bit. I would wrap it up at this point. Thanks everyone for attending. I hope this was semi-useful for you. As usual, please, if you got anything that anything that was unclear, anything that you'd like covered, wishes, rants, hate mail, whatever, feel free to reach out to me on Discord. There you can. So I'd suggest you can find me as Defolos on most chats on matrix.org. You can find me on Discord. So in case you want anything, just send me a message, send me an email, and I hope to see you next time. Thanks everyone.